In this video, we're going to learn how to solve this very interesting triangular pattern problem. We start to answer the question. I just want to highlight a couple of things which are very important for you to take note of. Right? The first one is this. You will notice that if we were to go to the site that is found in the description below, you will find that there are two questions very similar to each other. Right? This question is labeled, I believe, 27A, and this one is 27B. They look very similar, but if you were to look closer, you will notice that figure 1 in this question, you have only one diamond there, whereas in 27B, figure 1, you have three shapes there. Right? So the rest are all the same, but with this slight difference, it makes question 27B a bit more complicated to solve. Alright, so that is why I have a separate question on that, and I will also perhaps do a separate video to discuss that. Alright, that's the first one. If you look at on the right hand side, you will see this very famous past PSLE question. Alright, it looks similar because it involves triangular pattern, but I just want to highlight to you that this PSLE question is totally a different problem altogether. Alright, the answer is actually based on what we call square numbers. Whereas the problem that we are trying to solve today is based on what we call triangular numbers. Right? So if you are interested to find the solution for the past PSLE question, alright, the link is also given below, but I'm also going to create another video where I'll discuss in greater detail the differences between these two numbers, triangular numbers and square numbers, even though both of them can result in what we call the triangular pattern. Let's now tackle the question. Let's read the question first. Gundry uses diamonds and circles to form figures that follow a pattern. Okay, complete the table for figure 7. Part B, find the total number of diamonds and circles for figure 13. And lastly, a figure has a total of 300 diamonds and circles. What is the figure number? Right, so let's take a very close look at the figure as well as the table that is given to us and see whether we can see any pattern. Right? I think the first obvious pattern will be this, right? The number of diamonds. We have 1, 4, and 9, which are obviously a square. Alright, so 1 is actually 1 squared, 4 is actually 2 squared, and 9 is actually 3 squared. Right, so let's take a look at the figure 5 and 6 because both of them give the same number 9. Right, so but one of them is odd, 5 is odd, and 6 is even. So in order to get the same number, definitely the formula will be a bit different. Alright, but the 9 is actually 3 squared. So how do we get 3 squared from 5? Right. Or maybe we start with 6. How do you get 3 squared from 6? It's quite obvious, I think. We have to divide it by 2, and then we square it. Alright, so 3 squared is equal to 9. Alright, so perhaps this is the formula for even number figures. Alright, but 5 also give us 3 squared or 9. So how do we do that? We have to add 1 first to give us 6, and then divide by 2, and then we square it. Right? So this is 3 squared is equal to 9. Right? So let us check whether this is true for 3 and 4. Right? 4 is also even. So what we need to do is divide by 2 first and then square it. So 4 divided by 2 is 2. 2 squared is equal to 4. So we get our 4. Right? So what about 3? 3 is odd. Right, so we have to add 1 first, divide by 2, and then square it. So 3 plus 1 is 4, 4 divided by 2 is 2, so 2 squared equal to 4. Right, so that is the pattern for the number of diamonds. So we have to find that for figure 7. Figure 7 is odd. Right, so odd we have to plus 1 first, then divide by 2, then square it. So 7 plus 1 is 8, divided by 2 is 4, so it is 4 squared, 16. Right, so we know that this is 16. Next thing that we may need to figure out is how do we get this total number. Right, this pattern is not is not so obvious, but if you take a look at the figure itself, right, we can see something interesting. If you go to the top, there is a shape, right, 1 circle, below 2 diamonds, 2 shapes, 3, 4, 5, and 6. Right, so in other words, in order to find the total number, we just have to add up all those numbers. 1 plus 2 plus 3 plus 4 plus 5 plus 6. Right, so obviously we can just add up all this number using our calculator, but let's try to figure out what but that would be a big problem if the figure number is very big. For example, figure 13, which we're going to answer next. Right, so let us try to see whether we can find a more effective way of finding this sum. Right, so one of the trick is to do this. We're going to add another layer of this, but we're going to do it in the opposite way. All right, we're going to write 6 plus 5 plus 4 plus 3 plus 2 plus 1. Right, so you can see if we were to do that, each of these column will add up to 7. Right, 5 plus 2 is 7, 6 plus 1 is 7, 3 plus 4 is 7, and so on. All of them will give us 7. Right, and how many 7s do we have? We have 6 of them. Right, so we can find the total very easily by having 6 multiplied by 7, but then we must remember to divide by 2, because we are actually only interested in this, but now we are adding another one of that. Right, so that's why we have to divide by 2, and this simplifies to 21. Right, so that checks out here. Right, so let's apply the same method for figure 7. Right, so if you were to do the same thing for figure 7, you'll find that you are going to have 7 multiplied by 7 plus 1. Right, so you are going to have another one. Okay, let me erase this. Let me erase this. Erase this. Right, we are going to do this 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Right, and then we're going to add another one in the opposite way. 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. Right, so we are going to get 8 for all of them. How many of them? 7 of them. Right, in other words, the formula is 7, the figure number, multiplied by 7 plus 1, and then the whole thing divided by 2. So this is actually 7 times 8 over 2, or 7 times 4, which is 28. Alright, so the total for figure 7 is actually 28. Alright, since we know these two numbers, we can easily calculate the total number of circles, which is actually only 20, which is 28 minus 16, or 12. Right, it seems to follow the same pattern, right? So we can see now 2 is repeated, 6 is repeated, so 12 is also repeated. Okay, so that is for part A. Now let's answer part B. We are supposed to find the total number of diamonds and circles for figure 13. So I'm going to skip writing down all the numbers from 1 to 13. Alright, I'm going to use just the formula that we have learned. Alright, we're going to take 13 multiplied by 13 plus 1 and then divide by 2. Right, so this is actually 13 multiplied by 14 divided by 2. This is the same as 13 multiplied by 7. I believe it is 91. Right, so that's the answer for part B. What about part C? We have a total of 300 diamonds and circles. Right, so instead of dividing by 2, now we have to do the opposite, which is multiply by 2. We get 600. Right, so now we have to figure out what are the two numbers, consecutive numbers, right, which multiply together to give us 600. So we have to do a little bit of trial and error, and I believe if you were to do that, you're going to get the two numbers as 24 multiplied by 25. Right, so the figure number will be the smaller of the two numbers, so the answer is actually figure 24. Okay guys, now that you know how to answer this question, right, so it's time for you to test yourself. Go to the link that is given below, go to this site, click on the new problem button, try out different numbers. You can see the numbers change, and make sure you can solve the whole problem all by yourself. Right, so have fun and thank you for listening.